Hello viewers, welcome to another section of my tutorial, and I have a problem in applied electricity. It says if an ammeter is connected across the terminals A and B of this figure shown here, it reads 10 milliamperes, but if it's connected or if a 10 kilo ohms is connected, it reads 6 milliamperes. Find the current in a 15 kilo ohm load. So what will be the reading of the ammeter if a 15 kilo ohm is connected? So you can see that this is a framework problem from the Norton's theorem. And the Norton's theorem, we find the Norton's current, which is a short circuit current. Then we have the Norton's resistance, which is an open circuit resistance. Then we find the current through the load. So in the first scenario, there was no load, so that will give us our Norton's resistance IN. So that is 10 milliamperes. Then we have in the second scenario, they gave us a load resistor, which is 10 kilo ohms. Then the current that was passing through was the current reading, that is IL 6 milliamperes. So how will we get the Norton's resistance? So we know that from the Norton's theorem, a Norton's resistance is always in parallel with the Norton's Norton resistance is always in parallel with the Norton's current as well as the load resistor. So we use the current division to find the current through the load resistor. That's IL will be equal to Rn over Rn plus RL times the Norton's current. So from our scenario, our IL is 6 milliamperes should be equal to the Rn over Rn plus 10 kilo ohms, multiplying the Norton's current 10 milliamperes. So we make changes and we arrive at this. So Rn multiplying 6 milliamperes, you send it to this part, it will leave 60 to be equal to, when you subtract, you are going to get 4 times 10 to the power negative 3 Rn nicely. So from here we can get our Rn to be equal to 15 kilo ohms. So once our Rn is 15 kilo ohms, the question is saying that we should find the current in a 15 kilo ohm load. So here is a case where they have replaced the 10 kilo ohm with a 15 kilo ohm. So you write another equation. So to find the current IL again, we get Rn over Rn plus RL times IN. So making our substitution, we get our IL to be equal to the Rn, which is 15 over 15 again, plus our RL now from the question is 15 kilo ohms, and this multiplying the IN, and the IN from the question was 10 milliamperes. So what do we get from here? We get 15 over 30 times 10, and this will give us 1 out of 2 times 10, and it will give us 5 milliamperes reading. So when a 15 kilo ohm load is connected, we are going to get 5 milliamperes reading. This is a word problem from the Norton's theorem, and this is how we go about it to get the current reading of the 15 kilo ohms. Now let's go to the second problem I have for today, and it says that if a current I of t is 1.5 t squared flows through a 2 Henry's inductor, find the voltage across the inductor at 4 seconds. So from here, when you have an inductor allows AC to pass through. So AC is having a current function, that is the current of an alternating source is not constant, so it's always written a function of something. So you have our I of t to be equal to 1.5 t squared. So we have to find the voltage across the inductor, and we have the voltage of an inductor is generally equal to L di over dt. So where L is the inductance and di is the change of current over the change of time. So this will be equal to the inductance, which is 2 times, when you differentiate this, we are going to get 2 multiplied by 1.5, then multiplied by t, 2 minus 1, that will give us 3t. So what do we get? We get 6t. So from the question, the instantaneous or the time that we were given is 4 seconds. So we simply put 6 multiplied by 4 which is equal to 24 volts. So this is how we solve for the voltage across an inductor where there is AC source and the current function is given. Thank you. This is the end of my video. Kindly subscribe, share.